kiddos, we are getting into the nitty-gritty of some serious algebra stuff, at least where linear functions are concerned. We have spent a lot of time talking about slope and all the different ways we can use to find the slope of a graph or a line. We have also talked about x and y intercepts, and we've talked about what all of that stuff means in terms of a graph. Now we're going to start talking about the equations of those lines that we've been seeing. We've been graphing lines, we've been looking at lines, we've been finding stuff about lines. Now we're going to learn how to write the equations for those lines, and this is a very important concept. It's a very big deal, and this is some serious algebra. So, all linear equations can be written in several different forms, but the most common, and the one that you are going to see the most often, is called slope-intercept form. So any line that we can graph can be described by this equation, y equals mx plus b, where m is the slope of the line, and b represents the y-intercept of the line. I don't know why it is b and not some other letter, but it is b that represents the y-intercept. We don't have a special letter for x-intercept because when it comes to writing an equation of the line, the x-intercept doesn't have a special value, a special variable assigned to it. It doesn't have its own letter. It just is the x-intercept. So m is the slope, b is the y-intercept, and here is the form of the equation. You're going to need to know that. We're going to hear it often. We're going to use it a lot. So we're going to write the equation or the function rule that describes each of these lines in slope-intercept form. So everything we're going to write is going to be in this form, y equals mx plus b. Y and x, by the way, will just be variables. We will not plug numbers into y and x. They won't be anything other than y and x. And then m will be the slope and b will be the y-intercept. So for this first problem, I'm told that the slope of my line is 1/3 and the y-intercept is at 0, 6. So the y-intercept crosses the y-axis at 6. So this is my m and this is my b. And all I'm going to do is plug those into this so I can have an equation in slope-intercept form. So y equals, m is 1/3 x plus b, which in this case happens to be 6. The equation of this line in slope-intercept form is 1/3 x plus 6. And so now I can use that equation to go graph some stuff and get some big information. So let's do another one. Here I have my slope is 1 and my y-intercept is 0, 0. So my y-intercept, it is at the origin. It crosses right through the origin of the coordinate plane, right through the center. So this equation in slope-intercept form is going to be y equals, my slope is 1 and my y-intercept is 0, so it becomes 1x plus 0. And if you want to cancel out the stuff that's not important here, I don't have to put the 1 in front of the x. So that just becomes x. And plus 0, adding 0 to anything doesn't change it. So this is the equation of a line that has a slope of 1 and a y-intercept of 0, 0. This is the equation of a line. By the way, this is also the equation of the linear parent function. Every straight line comes from this parent function, the y equals x. Okay, so let's look a little more. So now we're going to solve these following equations for y, and then we're going to find out what the slope and the y-intercept are. So we're going to just solve for y, which means we're going to get y by itself. So if we look at this equation right here, negative 3x minus y equals 11. I'm going to try and get this y by itself. And so in order to do that, first thing I'm going to do is add 3x to both sides so that I can cancel it out and it won't be on the same side as the y. That leaves me with negative y equals, and I'm going to put the x first. And the reason I'm going to put the x first is because in this form, it is mx plus b, not b plus mx. It doesn't matter to me if you don't put the x first. It's just, it's a habit, and so that's how I'm going to do it. So I'm going to put the x term first, so I have 3x plus 11. Now, I don't have y by itself yet. There is a negative here, which is the same as saying I have a negative 1 in front of that y. So I have to divide by negative 1, and I have to divide all of this by negative 1. So that gives me y equals negative 3x minus 11. So here's that equation in y equals form. So it's now in slope-intercept form. The slope of this line, based on this equation, is right here, negative 3. The y-intercept is right here because that's the plus b. And so my y-intercept is negative 11, which you'll remember as an ordered pair is 0, negative 11, because that's the point on the graph. So let's do the next one. Let's do the same thing. We want to get this y right here by itself. So first thing I'm going to do is get rid of this x term, so I'm going to add 10x to both sides. And so I have 5y equals, and again I'm going to put the x term first, so I have 10x plus 20. And now I have to divide by 5 everything over here so that the y is all by itself. So I end up with y equals, well, 10 divided by 5 is 2, so that's 2x, and 20 divided by 5 is 4, so it becomes 2x plus 4. So now the slope of my line from here, because I'm in slope-intercept form now, the slope is right here, it's 2, and the y-intercept is right here, it's going to be positive 4, so it's at 0, 4. So there's your slope and your y-intercept. Now number 7 down here, if you want to write that down and try it, that would be fabulous. You can write it down and try it, and then come back and ask me tomorrow and check it and see if if you get the right answer. So let's move on and do another couple of other things. Now I have two graphs, and we want to write an equation for this graph. In order to write an equation, I have to find the slope of the line and the y-intercept of the line, because those are the two things I need for slope-intercept form. This first graph is a graph of a horizontal line. All horizontal lines, if you will remember from, we've talked about this for a long time, horizontal lines have 0 slope. So the slope of this line is just going to be 0. The y-intercept of this line, where does it cross the y-axis? Well, it crosses the y-axis right here. And that point is going to be 0, negative 3. So in order to write my equation in slope-intercept form, I'm going to do y equals my slope, which is 0x, because my slope is 0, plus my y-intercept, which is negative 3, so I'm minus 3. Now let's go ahead and take care of this. 0x is just 0, so it cancels itself out. So my equation of this line is just y equals negative 3. That's where the y in hoi comes from, because the equation of all horizontal lines is just y equals. And if you look at this line, every point on this line, y equals negative 3. Right here, y is negative 3. Over here, y is negative 3. Right here, y is still negative 3. So y is always negative 3 on that horizontal line. That's why that's the equation. So let's do the next one. I have this pretty little straight line. It goes diagonal this time, so I'm going to have to find slope and y-intercept. Y-intercept's easy. It's this point right here, which is at 0, 4. The slope, however, I'm going to have to find another perfect point, another pretty point. So there's one right here, and I'll do my rise over my run. So my rise is negative 2. And my run is 1, so my slope is negative 2 over 1, which is just negative 2. So this equation in slope-intercept form is y equals my slope, negative 2x, plus my y-intercept, 4. So the equation of this line is negative 2x plus 4. So now let's do something different. We're going to graph a line that has these characteristics. So I'm going to graph a line where m equals 4 and b equals negative 3. That means my equation for this is going to be 4x minus 3. So let's plot the y-intercept first. That means my y-intercept is going to be at 0, negative 3. So that point is right here. And in order to get to my next point on my line, I have to use my slope, which is 4. And in order to write 4 as a fraction, it's the same thing as 4 over 1. Which means from this point to the next one, I have to go up 4 and over 1. So that's what I'm going to do. I'm going to start here, the point I graphed already, and I'm going to count up 1, 2, 3, 4, and over 1, and it will give me another point on the line. And so now I have 2 points, and you only need 2 points to make a straight line. I will grab whatever I need. Oh, I will do a better job making a straight line in just a second. That was pretty bad. I will grab my ID or my badge or whatever it is that I need so that I can make a straight line, and I will draw myself a line that goes through those 2 points, and that is what that line looks like. So I have now graphed that, and that line right there has a slope of 4 and a y-intercept of negative 3. Now here's another one down here. If you want to try this one, you want to graph a line that has a slope of negative 2/3 and a y-intercept of 2. That would be you can try that, and we can check it tomorrow together. So one last example. For this following problem, we're going to write an equation in slope-intercept form, and then we're going to graph the line based on the equation. So step one, I got to get y by itself because slope-intercept form looks like this. Y equals mx plus b. The y is alone. So when it says write the equation in slope-intercept form, it means get y by itself. So in order for me to get y by itself here, I'm going to have to get rid of this minus 1/2 x. So I'm going to have to add 1/2 x on both sides. And just like I did a few minutes ago, when I do this, I'm going to do y equals, because that's what's left over here. And I'm going to put the x term first. So I have 1/2 x minus 8, because that is a negative 8. So my slope is 1/2. My y-intercept is negative 8, which means it's at 0, negative 8. So the first thing I'm going to do in order to graph this equation is put my y-intercept on here. So I'm going to go to 0, negative 8. So there is my y-intercept right there. And in order to get to the next point on my line so that I can graph it, I've got to use my slope, which in this case is 1/2, which means I rise 1 and go over 2. So I'm going to go up 1, over 2, and there is another point on my line. 2 points is all you need to make a line, but if you want another one, you can do it again. You can start at this point, you can go up 1 and over 2, and I could do this all day long and create a bunch of points on my line. Now you take a ruler or a sheet of paper or whatever you need so that you can connect those points and make a line so that you now have a line of that equation. Don't just connect the dots and stop. You are creating a line, and lines continue on forever in both directions. So you want to put the arrows on the end so that you can show that it goes on forever in both directions. If you just connect the points you plotted, you're making for me a line segment. But I want an entire line, so extend it beyond there so that you can see that it continues going. So that is slope-intercept form of an equation. Like I said, it's really important. It's something that you are going to need to know and be very familiar with. So I hope you have your notes all taken and nice and pretty, and I will see you tomorrow.